Hi guys, today we're working on combining logs. If you have more than one log, you cannot solve it, but we can smush these logs together and then we can end up with something that we can use algebraic procedures to solve. So let's look at an easy one first. Let's say log base, let's do 8 of r plus log base 8 of 4 equals to 2. Okay, so this problem is a little, it's not a simple one log problem. Now let's say we had a one log problem. If I say log base 8 of 64 is equal to 2, right? So because we know 8 squared is equal to 64. Okay, that's our basic idea. If I give you guys a variable, log base 8 of x is equal to 2. 8 to the second power gives us 64, right? That gives us 64 that we're hoping for. If I'm saying log base 8 of 64 is equal to 2, right? But instead of calling it 2, I call it x. 8 to what exponent gives you x? 8 to what exponent gives you not x, but 64. So depending on where we put the variable, it changes our problem, changes our dynamic, and we have different ways of solving it, right? But let's go back and talk about what if I have more than one log. So the goal here is we can only solve logs if there's just one log, not two separate ones. So we have to use our rule where if I'm adding logs, what am I really doing to combine them? And the rule is if I'm adding logs, I am multiplying them on the inside. So it's going to be r times 4. Of course, there's a prettier way to write this, and we're going to write r log base 8 of 4r. Because if I'm adding on the outside, I'm multiplying on the inside. Now, we solve this by doing the, we can rewrite this a couple different ways. Now, there are two ways we're going to solve this. I'm going to show you both ways. Now, if I have log base 8 of 4r equals to 2, since the r is stuck inside the log, we have two ways of doing this. One, we can do circle of logs. 8 squared is equal to 4r, right? We do this by using our identity. 8 to the squared is 4r. That is one great way of doing it because you know the identity already. If you don't know the identity, we can use the exponents of both sides. So let's do the long way. Log base 8 of 4r is equal to 2. The way you get rid of logs, we use exponents. We talked about this in class before. Because 2 is an exponent, so let's make it an exponent again, of the base 8. 8 is our base. So we do 8 to both sides as a base. The log and the base here cancel out, leaving you 4r equals to 8 squared, which is exactly the same thing as our identity. But we want to know this algebraic process. The way we get rid of logs is we use exponents. We make them both exponents on both sides. Because logs solve for exponents, so this was an exponent and this was an exponent. So let's rewrite those as exponents. From here, we can say 64 is equal to 4r, divide 4 to both sides. R is equal to, what's that going to be? 16. Okay. Now, is this true? Is log base 8 of 16 plus log base 8 of 4 equal to 2? Now, if you want to check this using a calculator, because does 8 times 8 times 8 times 8 really become 16? Does 4 times 4 times 4 really become 4? Nah, they don't. But if I rewrite this as log base 8 of 16 times 4, okay, what is 16 times 4? 16 times 4 is 64. Does log base 8 of 64 equal to 2? Yes, 2 squared is equal to 64. So r being 16 was our perfect fit here, and that's our goal. Would I have known this? Nope, not automatically. And this is one of our easier questions. So if we can use our log rules to solve for easy logs, we can definitely solve for ones that are not simple whole numbers, but would be decimals. And we would for sure have to use a calculator to solve for these. Now, let's try another problem very similar to this. I want you guys to see if you guys can get some bearings here. So if I write log base 4 of u is equal to log, no, sorry, not equal, I'm sorry, plus log base 4 of 2 is equal to 1. Okay. Now, can you think of a number that would work here? And in my mind, I can't think of a number, right? What exponent plus an exponent equals to 1? I don't know. 4 to what exponent plus 4 to the second exponent equals 1? I don't know. So let's rewrite this as one big log. Log base 4. And again, what do we do when we're adding? We're multiplying. I'm going to write this as 2 times u. The order doesn't matter here, so 2u. Now again, you can write this either by using identities, or you could use the exponent to both sides. I'm going to go ahead and do the exponent way, and if you guys want, you guys can do the identity way, but please be advised, really, it's not that much harder. If I try 4 to both sides, just a reminder, remember, 1 is an exponent, right? 1's exponent, so I'm just going to make them both exponents again with a base of 4. This cancels out, leaving you a 2u equals to, I'll write u a little better, 2u is equal to 4 to the 1 power. It's fine. And then we're going to divide both sides by 2. I would never have guessed u was 2. Maybe you could have, right? But log base 4 of 2 plus log base 4 of 2 is equal to 1. Now that I write it, maybe, because this would be log base 4 of 2 times 2. Has done 4 squared, 4 to the 1 power, I copied it wrong. 4 to the 1 power 4? Yeah, that actually would have worked. But again, it is not obvious, and it's something that we would, especially if it wasn't a whole number, we would never be able to guess. Now, if I want to use identities, let's jump using identities here from this step here, not from the original step. The original step we would have to always simplify. Circle of logs, 4 to the 1 power is equal to 2u. Right? If I do circle of logs, are you guys okay with the circle of logs? 4 circle of logs, 4 to the 1 power is equal to 2u. And in this case, it's just 4 is equal to 2u, u is equal to 2. Wow, that would have been actually a lot faster. But you need to know how to use exponents to get rid of logs, in case it's not obvious. Now again, this doesn't work if I write 4 over here. That does not work. Okay, that does not work. Okay, let's try another problem. Let's do one more that's not as clear cut here. If I write log base 49, that's a big number, w minus log 49, 2 is equal to 1/2. Now again, this isn't as obvious. That 49 is kind of a big exponent, but let's go ahead and write this together before we freak out too much. Log of 49 of w minus 2. Well, remember, if we're subtracting on the outside, we are dividing on the inside. So subtraction problem is really a dividing problem. And it goes 1/2. We can take, let's solve it using our exponent way. So I'm writing 49 to both sides. Now, I wonder if you remember, what is 49 to the 1/2 power? If you remember from Algebra 2, whenever you have a fractional exponent, that's actually a radical. So this is actually the square root of 49. And the square root of 49 is 7. Right? Square root of 49 is 7. 7 times 7. And then we can solve it by multiplying the 2 to both sides. W is equal to 14. I would never have guessed, whoops, I was going to write wrong. Log of base 49 of 14 minus log of 49, 2 is equal to 1/2. I would never have guessed that. Just to prove that this is true, without simplifying here, oops, hey Howards. Let's see, did I make a mistake anywhere? I think I'm okay. So let's go ahead and type it as we see it. Here we go. If I see 14, so okay, to remember the calculator, I need to write log of 14 divided by log of 45 minus log of 2 over log of 49. I'm not sure I wrote 45, 49 is, and we'll see if that gives us the answer 1/2, okay? So 14 log divided by 49 log, Okay, then we're going to minus this answer equals minus that answer from, I need to throw myself a parentheses here so I don't mess up, 2 log divided by 49 log, close that parentheses, and then we're going to hit equals, and we end up with 0.5, the 1/2 that we were hoping for. A lot more work than me just checking the other way. Log from here to here, that's log base 49 of 14 over 2. 14 over 2 is what? 14 over 2 is 7, right? 14 divided by 2 is 7. And is it true that 49 to the 1/2 power is 7? 49 to the 1/2 power is 7. Remember, 1/2 power is just a square root, right? The way we change an exponent, if it's a fraction, it's actually a radical. The fraction is my radical, and that is 7. We are good to go. So if we're adding and subtracting, we can combine those logs, and then we can either use our identity to solve it or use exponents on both sides. And it's important that we know how to use both. Now this leads us to working on other problems with, what if I just have exponents? What if it's log of 4x equals to log of 8? Now, if I have logs on both sides, this problem is actually cut and dry. Because if they're both logs, shouldn't the inside be equal to each other? Right? So if these are supposed to be identical, so shouldn't 4x equals 8 if these were truly equal? Now, for us to do this algebraically, the way I would get rid of the logs is I would just say, since it's an invisible 10, because it's a common log, you just write 10 on both sides, and guess what happens to the 10? That cancels out the logs. So we're left with 4x equals to 8. In this case, x would be equal to 2. So when you have logs on both sides of the equation, it's not really a hard problem, is that we just have to get rid of them. And whether you say, hey, since they're both logs, the insides have to be equal to each other, or we use algebra and you use the base on both sides, both would work. So here's another one that's not as obvious. Now, what is the base for natural log? Whoops, let me copy that wrong. We said before that if it's a log, this is called common log, there's an invisible 10 here. And natural log is a log with a little baby e on the bottom. It's a loggy. Aw, it's so cute. It's a baby loggy. But natural log is a base e. So for this problem, we can either just say, hey, look, since they're both the same log, we can just copy them. We can say negative v plus 12 is equal to 3v plus 8. Or we can say, hey, give them both the same exponent. But the exponent has to be the same as the base. Those go away. Negative v plus 12 is equal to 3v plus 8. In this case, let's go ahead and combine the v's. Right? And then divide by 4. V is equal to 1. Turns out the answer was 1. If I write natural log of negative 1 plus 12, is that the same as natural log of 3 plus 8? And this will give you ln of 11, and the other side, natural log of 3 plus 8 is 11 also. Okay, so same answer. That would have worked. Okay, so you can either use common sense, or you could have used our algebra, our inverse operation of logs, which is an exponent, and then make them exponents, and those will cancel out with the logs. Not very difficult. Just we have to practice it, so in case we do see it, we're not freaked out by it. Okay. And that's it. So I would spend the time not only catching up with this lesson, but if you haven't caught up with your other lessons, work on those first and then get to this one. Okay.